The perfect storm hasn't happened yet, but it may only be a matter of time. To see what I mean, let's take a look at New York City. By itself, Hurricane Sandy wasn't an exceptional storm. It was just a post-tropical cyclone when it made landfall. But it was perfectly timed for destruction. Peak winds coincided with an unusually high tide, causing the most extreme storm surge in the city's history. 9 years later, Superstorm Ida broke records with over 3 inches of rain in a single hour, overwhelming sewers, flooding the subway system, and causing massive widespread damage. But it could have been much worse.
Our urban infrastructure was really designed for the climate of the last century.
Compound flooding is definitely going to increase, largely driven by sea level rise.
We've already decided what the future is going to look like. It's going to be hotter, it's going to be wetter, it's going to be riskier. There's no doubt about that.
So what if a storm hits with both the rapid rainfall of Ida and the storm surge of Sandy?
That combination will be literally doomsday for our metropolitan area.
We know it's possible because it's happened before. And now the ingredients that made it are just getting even more extreme. And we're more vulnerable now than ever before. Meanwhile, New York is investing billions in promising flood prevention and response. It comes down to a race. So who's gonna win? New York City or the perfect storm? In 1821, a Category 4 storm with nearly the strength of Sandy's 13-foot tidal surge and extreme rain battered the city. Manhattan Island flooded all the way to Canal Street.
If the 1821 event repeats itself again with the level of development we have in the metropolitan area, then the damage could be really catastrophic.
But our modern infrastructure isn't the only thing ratcheting up this risk. So let's take a look at what specifically made Sandy and Ida so much more damaging than predicted. When Sandy hit New York, it coincided with a spring or king tide. And this is when the sun, earth, and moon all align, creating a higher tide than usual. The storm collided with winter weather systems, causing it to make an unusual westward turn while rapidly growing in size.
Hurricane Sandy's track was perpendicular to the coast, and that counterclockwise wind will push water right into the New York region.
The damage was catastrophic. A nearly 14-foot storm surge inundated the region. Hundreds of thousands of people were forced to flee their homes, and flooding in the electric grid and subway systems had ripple effects across the city.
It's surprising, surreal to look at the news and see southern Manhattan completely dark.
Ida, 9 years later, was a completely different storm. It made landfall in Louisiana as a Category 4 hurricane.
By the time it got to New York and New England, it had largely dissipated as a tropical system, but it still carried a lot of moisture.
Flooding from Ida occurred inland, far away from the coast, and it too caught New York by surprise.
Basements flood, and in some cases, people lost their lives because people didn't know they had flood risk in that area.
So what is New York doing now to prepare for the threats of extreme rainfall and storm surge? And will it be enough in the face of a changing climate?
In the last 10 years, the Department of Environmental Protection has invested about $5.6 billion in stormwater protection. And there's another $10 billion that's planned for the next 10 years.
Much of this effort has been focused on protecting the coastline, and for good reason. The city is deeply vulnerable to storm surge and coastal flooding. The city's front line against storm surge is called the Big U. It's a series of seawalls, floodgates, and raised berms that wrap around the tip of Lower Manhattan. And similar projects are proposed for other boroughs like Brooklyn, Queens, Staten Island, and the Bronx. East River Park is one piece of the Big U. The city has invested around $1.5 billion into raising the park by 10 feet.
There's over 100,000 low-income residents now protected by this park. That's a major investment by the city in an area that was basically deprioritized in the past.
But storm surge is only one part of the problem. Roughly 70% of New York's landmass is covered by impervious surfaces like concrete, which creates a ton of runoff in extreme rain events. New York's sewer system is currently equipped to handle up to 1.5 inches of rain per hour. Above that, the streets start to flood. Hurricane Ida had more than double that amount.
Many of the low-lying areas of the city, which is a large percentage of the total land area, are also going to need upgraded infrastructure to be able to deal with stormwater.
That's why the city is beginning to implement green infrastructure measures like rain gardens and porous pavement, which could make the city more absorbent and divert water away from the sewer system.
Parks in the city are starting to be redesigned for stormwater storage.
In the aftermath of Sandy, the city also installed floodgates at subway entrances to help keep water out of the subway system. When water does reach the subways and sewers, the city utilizes a system of pumps to remove it. The culmination of these promising adaptations represent one of the largest investments in climate resilience of any city in the US. So how do these efforts match up against the growing risk New York faces?
Hurricane Sandy had a 13 to 14 foot storm surge. So even this massive effort in coastal resiliency is still designed for a storm surge even lower than one we've already experienced.
As proposed, the Big U will cover 10 miles of the New York City coastline, but that's out of a total of 520 miles. To expand that level of protection around the rest of New York, the price tag would be astronomical. This is what adaptation looks like, but it's slow, expensive, and worse, it's built for the projections we have now. By 2080, the risk of flooding from extreme rain and storm surge will be much worse.
If we fast forward even 10, 20 years, it seems very clear that we're going to have to scale up the level of investment very dramatically.
There's no question that both Sandy and Ida were disastrous on their own, but they were also both considered 1 in 100 year events. So how likely is it really that a single storm could match both in intensity? Well, it's actually more likely than you think.
What we're calling a 1 in 100 year flood event actually occurs about every 35 years today when you correct for climate change.
The air temperatures are increasing a little faster than expected, and the sea levels are rising a little faster than expected.
Wind risk will greatly increase, storm surge risk will greatly increase, and rainfall particularly, without a doubt, is greatly increasing because of the physics.
So when it comes to the perfect storm, the question seems to be not if it will happen, but when. So with all the money that New York has invested in flood prevention, just how much flooding would we really see during a compound event like the one in 1821 with both extreme rainfall and storm surge? Or an even bigger one, supercharged by climate change? Thanks to the latest modeling from First Street, we can get a good idea.
We use physics-based models to provide trustworthy predictions of how's the physical world going to be changing over the next 30 years, over the next 75 years.
Taking into account warming, sea level rise, and the preventative measures that the city has put in place over the last decade, here's what New York would look like if hit by a 100-year storm surge event combined with a 100-year rainfall event. 25% of the city would flood, with some areas inundated by up to 20 feet of water.
There is no infrastructure that is built to handle those extremes. That combination will be literally equivalent to doomsday for our metropolitan area.
Low-lying neighborhoods throughout the city would be underwater.
That wall of water pushing into all parts of the city is a bit of a nightmare scenario, but one we absolutely have to think about.
With bridges and roads washed out, evacuation would be an unprecedented nightmare.
I think the biggest problem is that there's really no safe place.
So if the adaptation efforts in New York wouldn't be enough to prevent catastrophic flooding during a superstorm, does that mean New York is doomed? It doesn't have to be. But at this point, addressing the risk of extreme flooding may require a paradigm shift.
We're gonna have to learn to live with water. The idea is that water needs to be able to be safely conveyed, and we need a minimum amount of streets that we can continue to move on while giving up some of that space for floodwater.
This might mean raising streets to allow passage for emergency responders while using some low-lying streets as canals to funnel stormwater to parks or areas that can act as a temporary reservoir. Researchers at the Stevens Institute are working on radar systems to map rainfall across the city with precise detail and determine exactly where flooding is happening as it's happening.
We map precipitation at high resolution and then see how that precipitation, based on the last 2 hours, how it's going to evolve in the next 2 hours. We augmented our capability with in-situ sensors to improve the radar, but also to use them as an alert system on the ground. We trigger an alarm and we evacuate people. Sometimes the difference between life and death is only a few minutes.
With alert systems, designated access roads, and detailed flood maps, emergency services would be able to more efficiently plan and execute disaster response.
When I think about adaptation, I'm considering the cost of adaptation now versus the cost of recovery later. And every study has shown the dollar spent on adaptation is more efficient than the dollar spent on recovery.
And I know New York is just one city in the US, but as it attempts to adapt to our changing climate, it can serve as a case study for other cities that are also at risk.
The highest risk is in Florida, but some of that risk now is shifting north. New Jersey, New York, Long Island, Rhode Island, Connecticut, Massachusetts, those areas are going to become a little bit more risky.
It may be time for cities up and down the coast to start rethinking their infrastructure to be resilient in a hotter, wetter, and overall more extreme climate. We may not be able to avoid the next big storm, but whether or not it's a disaster is up to us. Before you go, I wanted to tell you about a side project that I've been working on. You may not know this about me, but I am a bit of a history buff. So I've been really excited to work with my hometown PBS station, Georgia Public Broadcasting, on a new history series called Marked. If you're into US history, especially in the Southeast and Georgia, this is the show for you. I had such a great time making this show. I hope you check it out, and if you do, I hope you like it. In show-related news, we recently joined Patreon in response to federal funding being eliminated to public media. If you are looking for a direct and simple way to help this show continue, please check out our link. Thanks so much.